New model of an atom. This is my model of an atom that I am forwarding to replace the current established model of an atom. The current established model of an atom is called Schrödinger's model of an atom, also known as quantum mechanical model of an atom, in which most of the current logo of an atom is Ruggley based, where the nucleus is a lump of proton and neutron and the electron orbit in random around the nucleus. There is no new development on the model of an atom and the subject seems to be settled. Or so it seems. To understand how I had discovered my new model of an atom, it is important to have a very brief background on the atom through the discovery of the subatomic particles, electron, proton, and neutron. Electron was discovered by J. Thomson in 1897. Proton was discovered by Ernest Rutherford in 1919. Neutron was discovered by James Chadwick in 1932. From the discovery of proton and electron, the physicists tried to determine the structure of an atom. Plum-pudding model of an atom forwarded by J. Thomson in 1904. In Thomson's plum-pudding model of an atom, the atom is a uniform sphere of positively charged matter in which the electrons are embedded. Saturn model of an atom was forwarded by Hantaro Nagaka in 1904. In Nagaka's Saturn model of an atom, the electrons are arranged in one or more rings, with the similar structure to the stable rings of Saturn. Rutherford's model of an atom was forwarded by Ernest Rutherford in 1911. In Rutherford's model of an atom, Rutherford found that the atom has a central charge, later called as the nucleus. Bohr's model of an atom was forwarded by Niels Bohr in 1913. In Bohr's model of an atom illustrated by a hydrogen atom, the electron orbit a proton, where the centripetal force is provided by the electrostatic forces between the proton and electron. Bohr had no explanation of why the atom is stable, he just asserted that it is as the electron do not collapse to the nucleus. In Bohr's model of an atom, when an electron jumps into another orbit, it is accompanied by an emitted or absorbed amount of electromagnetic energy. In 1926, Erwin Schrödinger took the Bohr's model of an atom one step further by using a mathematical equations to describe the likelihood of finding an electron in a certain position. Unlike the Bohr's model of an atom, Schrödinger's model does not define the exact path of an electron, but rather predicts the odds of the location of the electron. This is portrayed as a nucleus surrounded by an electron cloud, and where the cloud is most dense, the probability of finding the electron is greatest, while in a less dense area of cloud, the electron is less likely to be found. The Schrödinger's model of an atom is also called the quantum mechanical model of an atom. The symbol of an atom is a simple depiction of the Schrödinger's model of an atom with various depictions of the nucleus. Problems of the Schrödinger's model of an atom. 1. It cannot explain where is the strong nuclear force that hold the protons together as they should repel each other. 2. It cannot explain the equal number of proton and electron in the periodic table of the elements. 3. It cannot explain where is the electron configuration in the atom. 4. It cannot explain the charge of proton, neutron, and electron. 5. It cannot explain why does the electron orbit the nucleus, proton. New model of an atom. My new model of an atom forwards that the subatomic particles proton, neutron, and electron emits an energy field. The theory uses my charge theory so that the proton and its energy field spins in a counterclockwise direction, the neutron and its energy field does not spin, and the electron and its energy field spins in a clockwise direction. As will be discussed later, my new model of an atom explains most about the atom that the current established Schrödinger model of an atom cannot explain adequately. When I wrote my book Theory of Everything, I tried to understand how the atom was created. I already knew that the Sun is mostly made up of hydrogen atoms and that through nuclear fusion, helium is created. I also knew that hydrogen have what are called its isotopes, that is, an atom created from successive nuclear fusion up to the next element. An isotope is atom that has the same number of protons and electrons but with a different number of neutrons. So, in trying to understand how an atom is created, I looked at the hydrogen atom, isotopes of hydrogen, and helium atom. We can see that hydrogen has one proton and one electron. The hydrogen isotope deuterium has one proton, one neutron, and one electron. The hydrogen isotope tritium, which is actually radioactive, has one proton, two neutrons, and one electron. And finally, the helium atom has two protons, two neutrons, and two electrons. The inspiration for me was to imagine that the hydrogen atom is like a pancake that is being stacked and through nuclear fusion produce the isotopes up to the helium atom. The pressure or force exerted on the atom causes the proton to change into neutron, lose an electron, and emit other energy particles observed such as photon and neutrino. The pressure or force exerted on the atoms causing the nuclear fusion could be the combination of the force of gravity and mass above it, and the heat generated by the emitted energy particles. Future research will be on whether each step of the hydrogen isotopes is necessary to come up to helium. 3 hydrogen atoms will directly produce tritium, or 4 hydrogen atoms will directly produce the helium atom. My new model of an atom could easily illustrate the atom of an element that indicates how many protons, neutrons, and electrons there are in the atom by using the top view of the atom. The side view of the atom shows the electron configuration of the atom. The structure of the so-called nucleus is actually what I called the proton-neutron pole. Note that the structure of the atom when drawn in the proton-neutron pole could look like a Christmas tree, but in reality, the proton-neutron pole could be very close with each other, making the atom in the minute world of the atom practically flat, thus making the shape of the atom somewhat spherical due to its energy field. The problems that my new model of an atom had solved are the following. 1. Explain what holds the nucleus of an atom. 2. Explain why is the number of proton and electron equal in an atom. 3. Explain where is the electron configuration in the atom. 4. Explain what are the charge of proton, neutron, and electron. 5. Explain why does the electron orbit the proton. 1. What holds the nucleus of an atom? Currently in physics it is known that a strong nuclear force holds the nucleus of an atom, that is, the strong nuclear force holds the positive charge protons that are supposed to repel each other. In my book Theory of Everything I had shown that the up quark, down quark, electron, and proton are particles that are spinning and have their own energy field. The neutron's field is not spinning. Just like the magnet's magnetic field and the star, planet, and moon's gravitational field, the particle have poles. The strong nuclear force are the poles of the proton that holds the nucleus together, like stacking a magnet on its poles. 2. Why is the number of proton and electron equal in an atom? In the periodic table of the elements we know that the number of protons are always equal to the number of electrons. Why is this? The reason why the protons are always equal to the number of electrons is that the configuration of the hydrogen atom is always maintained, that is, one electron orbiting one proton, or rather, the proton making the electron orbit it. In the current model of an atom, the lumping of the protons and neutrons in the nucleus made the electron independent of the proton and has no explanation on why the electron orbit the nucleus. 3. Where is the electron configuration in the atom? In the Schrödinger's model of an atom, the electron configuration of an atom cannot even be seen from the structure of the atom. In my new model of an atom, the electron configuration of an atom can easily be seen by looking on its side view. 4. What are the charge of proton, neutron, and electron? As discussed in my video on my charge theory, currently there is no clear understanding of charge. In my charge theory, I had explained what charge is. That is, charge and spin are the same. Proton's field spins in a counterclockwise direction, neutron's field do not spin, and electron particle and its field spins in a clockwise direction. In Schrödinger's model of an atom, the subatomic particles of an atom are not spinning and had never been known to have poles like magnet. 5. Why does the electron orbit the proton? My new model of an atom showed that only one electron orbit a proton. The image shows that the proton, or rather the field of protons, spins in a counterclockwise direction, while the electron and its field spins in clockwise direction. The energy field of the proton reaches up to the electron. At A, both the fields of the proton and electron aid each other, or the proton and electron attract each other, which make the electron stay at a distance to the proton. At B, the field of the proton pushes the electron to orbit it. At C, the field of proton and electron repel each other, keeping the electron at a distance. So, the dynamics of A and C makes the electron stay in orbit, as at B the proton pushes the electron to orbit it. The same is practically could be said between the Earth and the Moon, and the Sun and the planets. I challenge all the brilliant people, physics teachers and professors, scientists, and physicists to compare the Schrödinger's model of an atom to my new model of an atom, as the implications of my discovery will be significant in the understanding of the atom of the elements.
Please give proper credit to the author for discussion of his ideas and theories. Thank you.